Samsung Galaxy S3, and this is being broadcast live on my YouTube channel as well as on Google+. We got some. Idea is we're going to locate the Uart port on the Qualcomm. I think it's TTY-HSL0. So we're going to be trying to find the hardware output for that Linux device. And that's going to require a little bit of teardown. We're going to modify the kernel a bit and then inject the kernel back into the device. And finally, we will be probing around the hardware to see what we can find. I expect this to take anywhere between about an hour to 3 hours. So these guys here, they may be dropping in and out of the chat. So, all right, let's get started. I'll go ahead and reposition this camera. So the very first thing that we need to do here is we're going to have to get this device booted up. And we need to get the ADB on it. So I'll go ahead and bring this window over here. And should be ready about now. ADB shell. C/. Okay, and because it's a Samsung, it kicked me back out. I love that about Samsung. cd/dev/block/platform/ as MMC/ by name. All right, and now we can pull the boot partition. ddif = /dev. I can just do /boot, and we will put that onto /SD card /boot.image, or we want to rename that original. All right, going back to the computer now, and I'm going to pull /SD card /boot.image, original. I'm pretty sure. Oh. Okay. I messed up. I didn't put the OF file. Let's just do this a little bit easier. ddif = /dev/block/platform/ MMC /by aim /boot OF = /SD card /boot original .image. All right, exit ADB pull /SD card /original boot.image. And I'll go ahead and start preparing things. Victor, Sammy, boot. Move original boot.image, Sammy boot, cd Sammy boot. Now we'll go ahead and extract this, and I've got this Linux package here called aboot-image, and we will do a -x /original boot.image, and as you can see here, it's extracted that the partition that I just pulled off the device into its parts. So what we want to do now is gedit the boot image.cfg, And I'll go ahead and screen share over to there. Now, in order to make this thing recompile, we're going to change the boot size. It's not going to be exactly what it was before. And we want to enable the console. And instead of it being null like it was before, we want to make that TTYHSL0, or is it HLS? Oh geez, I need to do a Google search really quick. The TTYHSL0. Yeah, that's it. All right. And we want to set the parameters on that 115200 bits per second, no parity, 8 stop bit, or 8 bits per byte. And now we want to make log level equals 9, which should show every single bit of output from the device. And I have no idea what this user debug equals. Well, let's go ahead and close this out. And I'll go back to this terminal over here. All right, so what we want to do now is we want to use a boot image, and I always type a boot image first just so I see this little command line parameters thing here. So what we're going to do is a boot image dash create boot.image dash f boot image config dash k z image dash r init ram disk image. And we should have a new boot.image. All right, so next we'll do an ADB reboot download to put this device into download mode. All right, so now we're in download mode. So let's go ahead and we want a Heimdall dash flash boot. No, I got that wrong. Flash dash boot dot image. All right, now if this thing boots up at all, it should be a freaking miracle. All right, there you go. Now you notice that it's kind of jerky now. It's actually sending all of the Uart output, and there's a ton during the boot sequence. Now, because it's sending so much output, it's actually locking up the processor a bit, trying to get all that output out of the buffer. So it's a little bit jerky on the startup, but other than that, there should be no real difference because it's basically just sending the demessaged outputs to the Uart port. All right, so I guess now we're going to go ahead and begin the teardown. And because I just don't really care, I'm just going to pull the battery straight out of this device. And we'll go ahead and remove these screws here. You know what, I'm just going to do this a little bit quicker. So yeah, I didn't mention this. I mentioned this to some of you guys in the stream, but I didn't mention this to anyone on the YouTube video. I got a project going on, the Open Galaxy bootloader with XDA Elite recognized developer Rebellos, and also Relic Dev, Elite recognized developer Relic Dev. We're actually working on booting the Exynos 4412 processor using a version of U-Boot, which we're calling the Open Galaxy bootloader. Now, we actually have this thing working and it's fast booting, but we're running into issues with the trust zone on it. And the sooner we get this thing worked out on the Galaxy camera, which is what this is right here, you're actually looking at me on a Galaxy camera, the sooner we get this issue worked out on the Galaxy camera, the sooner we can get working on to other devices like Galaxy S3. Personally, I find the Galaxy camera to be a very good device to work with. It's just, I mean, it's got a very solid chassis on it, and the Uart ports are very accessible. The eMMC disable is very accessible, and I was able to, because it's got a metal chassis on it, I can actually glue something to the outside of it and not really have to worry about it kind of falling off or whatever. But ended up putting a little button so I can switch modes between the normal Galaxy camera and the Open Galaxy bootloader. Now, eventually, we're going to get this thing booting to the point where we're actually getting software up and running, and that'll help out a lot with the Samsung Galaxy S3 bootloader brick bug that's going on. I haven't heard any kind of news as to whether or not that affects the Galaxy camera, and I would be pretty upset if it actually did. Kind of rambling here, but yeah, eventually we're going to be getting the Open Galaxy bootloader booting onto the Galaxy S3, and that will be a pretty major thing. You ever try to work with an echo on? Because you can't really turn down volume in Hangouts. You can only get it down to the minimum volume, but for some reason it won't let you go any lower than that. So I got this camera right above me echoing everything I say. This one screw is just kind of getting annoying. There we go. I'm really a fan of how easily the Galaxy S3 comes apart. It's not really that difficult to get everything off of it. Now, take that and compare it to like the Droid Charge or the Galaxy S1 or the Galaxy S2. The Galaxy S2 is probably about the worst device to take apart. It is like pressure fit in place. And there's one more screw somewhere. Alright, so this is the board. And you probably can't see that very well. Let's see if I can get some light on the subject. I don't know how well that's going to come across.
It's still showing the terminal screen for me.
Oh, is it? Oh, darn. Oh, you know what? You've got it clicked on the terminal screen. Click the terminal screen again, and whoever makes noise, it'll flash around to them. Can you see that?
No, I'm on my phone though, so that might be why.
Yeah, well, let me unscreen share that terminal and see if I can move it over here. Okay, now the terminal is no longer showing. All right, so moving on a little bit. I wanted to see if I could find some sort of an eMMC disable on this device. Not that it would actually be possible to boot anything off of eMMC because the bootloaders on this device are pretty locked down, but more just because I wanted to see if there was any structural things that I could identify from Samsung, and it really doesn't look like there is. So let's get this thing back together and get it booting up and start locating Uart. Okay, so I'm pretty sure that there must be a debug port underneath this SD card thing. The shield. No. So I'm looking for the debug port. I'm not really seeing it. It's not going to be a typical Samsung debug port, I guess. Does anyone here have experience flashing JTAG onto this device? I'm really looking for that port. Um, kind of locking up a bit, I guess. Are you guys seeing that lag?
Now it just did, I think.
Rarely, but it's not bad at all. I'm very watchable.
Okay. Alright, it might just be my receiving lag. It must be transmitting fine, I guess. So I'm seeing a bunch of ports here, but I'm not really seeing any kind of a cluster unless... Alright, I think I've got it. It's right here. This point right here would be the JTAG port. Alright, so I'm going to put that final screw back in, the last one that I took out, just to keep this board in place. Alright. So, next up, I guess we can put this back on just for the safety's sake. There we go. Alright, so let's insert the battery and turn this thing on. So as you can see, it's booting up. And we've obviously got Uart going on because of how glitchy it is on startup. So the next thing we want to do is turn on the Uart device that we're going to be using to communicate with this. And I'm using a bus pirate. That's this device right here, as you can see. Let me switch on back over here, and now the way to initialize the bus pirate is I use minicom -d/dev/tty USB 0. All right, good. It's either USB 0 or USB 1, and I never know which one's which because sometimes my ADK initializes before the bus pirate does, and I end up trying to connect up Uart to my ADK, which doesn't really do much. The you know that little clock? That's ADK. I don't want to do this just yet because what I did was I selected normal mode, I would rather be probing around with open drain first. These two options right here. High is high Z, which is high impedance, and that means that basically it just turns off whenever it does a high. This right here, the normal mode means it's actually sending voltage over. So rather than start off with something that can destroy the device by sending voltage over, which it may want 1.8 volts, I could end up sending 3.3 over. We're going to try with a non-destructive method first before we do the potentially destructive method. And there we go. So next up, what I'm going to want to do is bring over to this window, and we want to ADB shell into the device, su cd/dev, and ls ttyh asterisk. All right, so now I'm not sure if I have BusyBox on this device or not. All right, looks like I do. T. All right, I got T date. All right, good. Okay, so we got BusyBox. We got all the commands we need. ls asterisk ttyhs asterisk. Now the device we want is ttyhsl0. So that one should be a direct port over to the hardware. And now what I'm going to do is I'm going to try to write something, the date command, over and over and over again, which contains the time as well. So every time it updates, I'll know it's sending something over to there. So what we'll do is while 0, so basically forever, do date, and then we want to t, and we want to put the date command onto the terminal, and then we want to put it into the /dev/hsl0, so it basically tees it off, ttyhsl0. And now we want to sleep 0.5. Now the Android system sleep, now the Android system sleep, it doesn't usually handle the 0.5, 0.1, but BusyBox sleep 0.1, and it works. And you see the system sleep here actually doesn't handle increments, small increments of a full second. You actually have to specify a second. But the BusyBox one, you can see it didn't give me an error there. It just slept for 0.1 second and continued on its way. It's a good little tip there. All right, so let's go ahead and start this little cycle that we got going on here. And it looks like my camera's gone offline, which is not good. I guess I'm going to have to exit out and join the Hangout again. There was a system error on my camera. It crashed out of a talk, Google Plus Hangouts. It's saying I couldn't enter the Hangout. Try again. Couldn't enter Hangout. Not really sure
Is there too many people? I can leave.
No. We should have. We should be able to have up to 10 people in this hangout. I'm gonna have to restart this camera, I guess. You know what? Until then, well, I guess I can't really do both streams at the same time. This thing keeps on kicking me out. SU while 0 do date t/dev/tty/hsl 0 busy box sleep 0.5 done.
Hey Adam, sorry to interrupt, but I'm going to have to drop off.
That's fine, Hod. Did you get that email that I sent you a while ago?
Yeah, I got something. I gotta go back and look it up, but it was the camera one.
Yeah, that's it.
Yeah, okay, yeah, I'll take a look. I've been at CES, so I've been kind of busy, but I'll try and get back to it.
All right. Yeah, well, it wasn't just about the camera, though. It was about pretty much all Samsung source. The problem is that, they're basically pulling part of the source code out when they unrevision it.
Okay, I'll double check. I don't know that I remember that one, but I'll take a look for it.
All right. Well, thanks.
Yeah, all right, talk to you later.
Have a good one.
Bye.
I texted you today before I talked to him on the phone.
All right. There we go. Yeah, a little bit of quiet, huh? All right, so now still trying to get my camera back up in operation here. Gotta go to profile, and then I should be able to hit this join hangout button. Well, it looks like we're gonna have to do this without the assistance of that camera. So I guess next up we can go ahead and bring up just this window right here. Now, this device is already grounded over to my computer via the USB cable. So what I'm doing now is I'm going to go ahead and probe each one of the pins on the device and see if I can get any kind of output. Now, the reason I put the date command on there is because when I'm working on the small electronics, I'm working on something about the size of a needle, and I'm using a needle. So you never know when you might restart the device, and that's what I just did just now. I just restarted the device. So I'm going to have to wait for it to restart, and in that time I'm going to create a little script here that'll make it a little bit easier to run that command in the future, the commands that I need. There we go. All right, so we want that while 0 do date tt/dev/hsl0. No, tthsl0 busybox sleep 0.1 0.5 done. Alright, so now I got a little note of that. It should be a little bit easier for me to restart this test in the future. I got to the second pin so far, and there was a little problem. It ended up rebooting the device. Alright, so there we go. Now this is basically my online monitor right here, and I'm muting you, Lauren. You're making a little bit too much noise. This is the online monitor right here, and ideally it'll just give me a heads-up glance and tell me if I've killed the device or not, which is really frequent when locating Uart. So back to the Uart window, and as soon as we find the Uart on here, that window should be displaying exactly what is in the date window. So there was the third pin. That's the fourth pin. I need that date window up.